Okay, so in the last video, we spoke about simplifying rational functions by a monomial, so like a common factor, which is just like x or like your GCF. But here we're going to do it by a binomial, so it might be a common factor that is not necessarily a monomial. So yes, you are going to have to use your factoring methods here. Lo siento. So again, just a recap. Step one, right? So like step one was factor, numerator, and denominator. Two was to find the domain by setting the denominator not equal to 0. And three is to cancel out any common factors. The steps did not change. The steps are still the same. So let's get to it. So we have to factor the top and the bottom. So what factoring method are we going to use? Well, I see that it's a difference of x squared and 9, so it's a difference of perfect squares. I'll write that. Difference of, I'll write it this way. Difference of squares. And so we're going to get a little factoring review in. It's x plus 3, x minus 3. And then this is the easiest one. Well, I have to check if it's factorable, but I can see that it is. So this is going to be reverse FOIL. So what multiplies to this and adds to this? And what two numbers multiply to 6 and add to 5? It is going to be x plus 3 and x plus 2. So where is my almost forgot, domain. See, it's so easy to forget because you see the common factor and you want to cross it out. But you have to find your domain first. So it's all real numbers, but x does not equal what? We set these equal to 0, and I get -3 and -2. Okay? And so, because a lot of the questions that you're asked is, okay, simplify this, and what is the domain? And then you can cancel out. This goes away, because they are the exact same thing, so they can be canceled out. And so it's simplified to x minus 3 over x plus 2. One of the biggest mistakes people make, yep, that's English, is they simplify it and then they will find the domain here and just be like, oh, all real numbers, but x does not equal -2. Not true. Even though this and this are equivalent, technically these two things have different domains. This is the domain, this green part right here. It is the domain of this and the domain of this because, and we're going to go into depth later on as to why, but when we graph it, we're technically going to graph this, but it still does not exist at x equals -3. There's something that we call a hole. So like the function will look something like this, where it's like, oh, everything exists leading up to it, but there's a hole there because the domain did not work in the original problem. So again, the domain does not change even if the function looks different afterwards. Let's try another one. So we got to factor the top, reverse FOIL. Boom. And the bottom is going to be difference of squares. So the bottom's easy, x plus 1, x minus 1. And the top is difference of reverse FOIL. So what two numbers multiply to 2 and add to -3? So it's going to be x minus 2 and x minus 1. And so my domain is all real numbers, but x cannot equal positive and -1, right? Plus or minus 1. And then I can cancel out what? My x minus 1. If there's no common factor, which might happen, you just say it's simplified. The same way that if I gave you a fraction like 2 over 3 and I said simplify it, you'd be like, Miss Masood, you're on something because it's already simplified, right? If I told you to simplify this, for example, you'd be like, it's already simplified. I can't simplify it any further. Okay, let's try another one. I encourage you to try it on your own, but I'm going to do it pretty quickly because if you know how to do this at this point, you don't want to sit through me explaining every single step. Okay, so reverse FOIL. What two numbers multiply to negative 15 and add to negative 2? So I have 115, not going to work. I have 3 and 5. 3 and 5 will work, right? So it's going to be 3 and 5. One's going to be negative and it's going to be 5. So minus plus. Negative 5 plus 3 is negative 2. Negative 5 times 3 is negative 15. And same concept here. It's negative, so one's going to be positive, one's going to be negative, and it's going to be 2 and 3. So plus 3 minus 2. Domain, all real numbers. X cannot equal 2 and negative 3. Boop, boop. And then what can I, what can I cancel out? These x plus 3's. And so I get x minus 5 over x minus 2. Okay, and then this is, actually before I do this, I just want to do a quick one where we have slide and divide, right? So if I have something like, oh God, I hate making up problems off the top of my head. So if I have like x squared plus, or you know what I'll do is I'll just go through a quick problem of what slide and divide, like just a review problem of slide and divide. So if I have like 2x squared plus 5x plus 3, right? So just a quick review. Yeah, so this goes like this, right? You slide, you get x squared plus 5x plus 6. You do your reverse FOIL, x plus 2, x plus 3. Then you divide by that 2 that you originally multiplied and your a value. This simplifies to x plus 1. This 2 comes up front to 2x plus 3. So let's say you had a function like x squared plus 3x plus 2 over 2x squared plus 5x plus 3, right? This one on top, we do reverse FOIL. So we get x plus 2 and x plus 1. And then this one down here, we just factored it. X plus 1 and 2x plus 3. Now, what's the domain? The domain is all real numbers, but x cannot equal negative 1, and I set this equal to 0, and I get negative 3 over 2. And then what cancels out is the x plus 1, and so we'll get x plus 2 over 2x plus 3. A lot of people struggle with the 2, and the advanced problems have the slide and divide in it. It also has u substitution, so you should probably go over your u substitution. If you need help with that, let me know. Lastly, you'll see problems like this. Like this is already factored, right? If you factor it and you see something like this and you're like, okay, something's up, right? Nothing cancels out because nothing's identical. But if you notice, if you see this right here, right, you have 3 minus x and then x minus 3. They're opposites versus x minus 1, x plus 1. These are not opposites because there's still a positive x, but then 1 is negative. Here, you have a positive 3, negative 3, positive x, negative x. They're exact opposites. So what you can do for here is you can factor out a negative, but a negative 1, technically, right? So if I factor out a negative 1 out of this, right? So I'm going to write it over here. If I factor out a negative, I'll put -1, but technically you're just factoring out a negative, right? So -1, then I get -3 plus x, right? What is -3 plus x the same thing as saying? It's the same thing as saying, you know what, let me write this here. 3 minus x. If I factor out that -1, I get -3 plus x, and which is the same thing as saying -1 with x minus 3. Now we have a x minus 3, which is what we wanted. So I end up getting -1, x minus 3, x minus 1 on top, and then I get x minus 3, x plus 1 on bottom. And then what cancels out? These two cancel out, and I get negative x minus 1 over x plus 1. That's factored technically, or I'll write it down here. Or you would get negative x plus 1 over x plus 1. Or, right, there's a few ways you can write this. You can write 1 minus x over x plus 1. I would not write it that way, personally. That's me. I like things in standard form. So these are both correct. This is factored, and this is expanded. Make sure you read instructions where it asks you for expanded or not expanded.